How's it going, guys? Today we're going to be reviewing another interview question. Today our interview question is called Rotting Oranges, and this is a question that's being asked by Amazon right now. I don't really care if you cry. Not already should never lie. Should've saw the way she looked me in my eyes. She said, baby, I am not afraid to die. Alright guys, so today we're going over another interview question. Today our question is called Rotting Oranges, and this is actually, as of right now, like late February 2020, this is, I think, is the third most frequently asked question according to LeetCode from Amazon, so it's a super important question to know. It's labeled as an easy question. There are a lot of people complaining that it's not that easy. I don't think it should probably be an easy question, but again, like I typically tell people, don't really worry about what LeetCode says, what the labels they use for questions are, easy, medium, hard, it doesn't really matter. What matters is what we know how to do the problem. So that's what we're going to do today. We're going to review this question, and our problem description says, in a given grid, each cell can have one of three values. The value 0 represents an empty cell, the value 1 represents a fresh orange, and the value 2 represents a rotting orange. Every minute, any fresh orange that is adjacent, meaning four directionally up, down, left, and right, to a rotten orange becomes rotten. And they want us to return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1 instead. So you can think about this as like being at a food court or something, or like a, I don't know, a fruit market or whatever, and there's basically a bin of oranges. At least one orange starts as infected or rotten, and every single minute that passes, any fresh orange that's next to any rotten orange becomes rotten. And so the rot, I guess, of the oranges will kind of slowly trickle out and infect all the other fresh oranges only if they are next to a rotten orange. And so we're basically asked to return the minimum number of minutes that will take for all the oranges to become rotten. And if it's not possible, right? Like if maybe there's a fresh orange that's further away than one cell from any rotten orange, then it's impossible, and we'd return -1. So if we look at our example here, they give us this input or this grid as a 2D integer array basically, and again those numbers represent those values, right? So 0 is an empty cell, 1's a fresh orange, 2 is a rotten orange, and so they kind of draw it out here in a nice diagram for us. So this was our starting diagram. In the top left corner was rotten. This is what the board would look like after the first minute, and the reason for that is after every minute, any adjacent fresh orange to a rotten orange, four directionally, right, up, down, left, and right, will become rotten. So after the first minute, the top left corner has infected this cell as well as this cell. After the second minute, now these oranges are also infecting other oranges, right, which is why this cell becomes infected or rotten, and this cell becomes rotten as well. Continuing that fashion, right, we see after the third minute, this orange has become infected, and after the fourth minute, finally, all the oranges have become rotten. So hopefully that makes sense, and that's why we return 4 here, because after 4 minutes have elapsed, all the oranges on our grid or in our board have become rotten. So here we'd return -1, and you can kind of trace through it if you want. We don't really have a nice diagram here to explain why, but effectively, rotten only happens four directionally, right? And so there's one orange that's far enough away, or maybe is diagonally placed from, like a fresh orange is far enough away from a rotten orange that it can never become infected. And therefore we'd return -1 because not all the oranges can become rotten. So let's talk about how to do this. And kind of by going through this diagram, we can sort of see that it's like a graph traversal, right? Slowly this cell infects these other cells, then the infected cells continue to infect additional cells. And this kind of makes us think of like a BFS, right? So slowly but surely, the rot of the oranges is spreading throughout the rest of the board. And that's actually how we're going to model this problem to be able to solve it here today. So I think the first thing we really want to do is we just want to know the state of the board initially. So I really want to know what oranges are fresh and what oranges are rotten. And from there, we can kind of start our BFS, right? So I know initially that we're going to have one orange that's rotten, and we're going to see from that rotten orange what other oranges can we infect. And if we ever get to a point where we try to simulate rotting all the additional or adjacent oranges, and we can't infect any additional oranges on that iteration of our BFS, then we know that, okay, we can't get any further. If we still have fresh oranges,
then we could return -1. And otherwise, we're just going to simulate running a BFS, right? So starting with that top left corner in this example here, after the first minute, it will have infected 2 additional cells, and then we'll take those 2 additional cells and basically try and simulate the next iteration of our BFS. So let's try and get that code down here. I said the first thing we want to do is try and get the initial state of our board, and the way we're going to do that, we're just going to use 2 different hash sets so that we can have fast access to whether or not a specific cell is rotten or fresh. So we're going to have 2 hash sets. So I'm going to say set of string, and I'm going to call this fresh equals new hash set. And then we're going to have another hash set of strings called rotten equals new hash set. And again, these are just going to contain all the different coordinates of oranges that are fresh or rotten. So now we just need to iterate through the board, populating these hash sets. So we're going to say for int I equals 0, while I is less than grid.length, I plus plus, for int j equals 0, while j is less than grid I dot length, j plus plus. And now we just have to check those 2 different values, right? So we said that 1 is a fresh orange and 2 is a rotting orange. So if grid of I, j is a 1, we're going to say fresh.add, and I'm just going to put an empty string here to make sure that these 2 coordinates get converted to a unique key as a string. And I'm going to say I plus j, and then else if grid of I, j is equal to a 2, then that means that that cell has a rotten orange, so we want to say rotten.add empty string plus I plus j. Great. So now once we get down here to line 15, we successfully have hopefully populated 2 different hash sets, one containing all the coordinates of fresh oranges and one containing all the coordinates of rotten oranges. So now we just need a return value, right? And we want to return the minimum number of minutes that must elapse until no cell has a fresh orange. So initially, our minutes will just start at 0. And then the other piece of information we have here is that fresh oranges can be infected by rotten oranges, right, 4 directionally. So again, up, down, left, and right. So I want to keep track of those directions basically and make sure that I can like loop over them or always consider those 4 directions for any of the rotten oranges that we're going to consider. So I'm going to say int as a 2D array directions equals, well, the 2 directions we could have are 0, 1, 1, 0, -1, 0, and 0, -1. So what this is really saying is that this first direction would be just moving down 1 cell. This direction would be moving to our right 1 cell. This direction would be moving to our left 1 cell, and this would be moving up 1 cell. So that's going to make sure that for every single rotten orange we see, we consider looping through those 4 directions to see if we can infect any fresh oranges. Great, so now we want to start our BFS, right? And so I'm just going to try and model this basically. I guess it's technically slightly differently because we're not using a queue, but it's the same sort of idea. I'm just going to say, while our fresh dot size is greater than 0, we want to try and infect other fresh oranges, right? Or simulate them becoming rotten from the rotten oranges near them. So while we have fresh oranges, let's see if any more oranges can become infected. And so the first thing I want to do is just make another hash set that's going to contain all the infected oranges that become rotten on this iteration of our BFS. So I'm going to say set of string infected equals new hash set. Great. And so now what I want to do is, now that I'm inside this loop, I want to basically go through every single rotten orange that I have and see if any of those oranges will infect any fresh oranges around them. So now I could say for every, let's say, just string s in rotten, which again represents all of our rotten oranges, we want to see where we are on the board, right? So we have basically coordinates here, and we want to say the I value, right, of that is going to be the first character in that string. So I could say this is s.char at 0 minus a 0. And what that's going to do is it's basically going to say, let's say that was like a 2. It'd take the character 2 minus the character 0, and that would actually just give us integer 2. So it's just a nice easy way to convert from a character to an integer. And then we're going to do the same thing for j. So j is s.char at 1 minus 0 as well. And now we have the coordinate of the rotten orange that we're currently iterating over. And now we said we want to check the 4 directions so that we could see if any of the surrounding oranges or any of the neighboring cells of the rotten orange will become infected, right? So I could say for every direction in our directions, now we can calculate the next I and the next j value based on that direction that we currently have. So I could say int next I equals direction of 0, and int next j equals direction of 1. And so that's just going to simulate getting us to our next cell, right? Taking that direction and applying it to our current coordinates I and j. And now we just want to check, okay, is the coordinate of grid next I, next j fresh? And if it is, it has become infected because it's next to S, which is the current rotten orange that we're on. So that's as simple as saying if fresh.contains, and again, this is going to be an empty string plus next I plus next j, then we've actually successfully infected this orange that is fresh. So if fresh contains that coordinate, there's a fresh orange there, and it's now become infected. So we could say fresh.remove this key. And then we could also add that infected orange to, or this now rotten orange, to our infected hash set. So we can say infected.add that same key. And so if you guys wanted to, you guys can make this variables, but for now we'll just get the problem done. Great, and so now what we will have actually done at the end of this loop, right, we've gone through all the rotten oranges, and hopefully, or maybe not, I guess it doesn't really matter, I'm not hopeful that we do or don't, we'll see if we've infected any additional oranges. And so if we have, then we need to continue looping, right? We need to take those new infected oranges and imagine, continuing spreading that rottenness throughout the remaining cells that they can now touch thanks to the new infected set, right? But if we haven't infected anything, then we know that we can terminate our problem because we're in this loop, right? And fresh is still greater than 0. So we can't actually reach any fresh oranges that are still available. So we could simply check if infected.size is equal to 0, then we could just return -1 right away because we know there's at least one fresh orange that we cannot reach, right? Our BFS is effectively terminating and we're done. Otherwise though, we want to continue our BFS, right? We want to continue trying to infect all the other cells. So we want to set rotten equal to infected. Great, and then after that, all that's left to do is increment our minutes, right? Because that was one iteration or one simulation of a set of fresh rotten oranges infecting the neighboring cells. So now once this terminates, all we should have to do is return whatever our minutes was, right? Or amounted to if we never return -1 here. So I think that should do it. Hopefully that makes some sense. So just as a quick overview again, we're going to first just get the initial state of the board. We're going to get a set of fresh oranges and rotten oranges by just iterating through the board, seeing which one's which, putting them in the appropriate hash set. Then we're going to initialize our minutes and our directions, basically just starting boilerplate stuff, right? Our minutes will start at 0. These are the 4 directions we need to consider. And while we have fresh oranges, we're going to try and infect those oranges. And we're going to keep track of whatever oranges we infect on this iteration of our BFS. Then we're going to iterate through all of the rotten oranges. And for each of the coordinates of each of those rotten oranges, we're going to look at the 4 directions they have access to and see if fresh contains any of those neighbors. And if they do, we're going to add it to infected and we're going to remove it from the fresh oranges. And once that loop terminates, if infected size is 0, we know that we can't actually reach all the oranges, so we could return -1. And otherwise, we're just going to update the rotten oranges to be the newly infected oranges so we can continue our BFS and we'll increment our minutes. So in terms of our runtime now, right before we submit this, I think the runtime would basically be O of n. And we could just say n is the number of cells in our grid because this is just basically a BFS. Even though we're going through all 4 directions here, no matter how big our grid is, right, that's a constant. We're only considering 4 directions, so we don't really have to consider that. So I think that our runtime would be O of n, where n is the number of cells in our grid. And I think our space complexity really here would also be O of n because we're using these hash sets to store fresh and rotten oranges. So with that being said, let's submit this code. Let's see if it works. Oh, Oh, oops, and that's actually because I forgot to say our next I is I plus our current direction, and our next J is J plus our current direction. Sorry about that. So let's run that again. Let's make sure that works. Awesome, and it does. So guys, that's how to solve rotting oranges in Java. Again, this is like the third most frequently asked question at Amazon right now. So I hope this is helpful. If it was, be sure to let me know, leave a comment below. If you guys enjoyed the video, be sure to leave it a like and subscribe to the channel for more. And I'll see you guys in the next one.
Yeah.